Yeah. Am I audible? Hello. 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 Please let me know the audibility. We are going to start one of the very important class that is about our SVJNN previous electrical engineering paper solutions. So 60 question solutions we are going to see in this module. Yes, please let me know whether I'm audible or not. Yeah, fine. Thank you. Thank you. So let's see the first question. The first question is very simple. See, not only first question, most of the questions which were SVJN exam are very simple. Okay, so we are going to solve these problems in a very simple way. One point I want to give here, that is, if you want to prepare exams like SVJN or HPCL, you have to cover the entire syllabus, all the corners of the syllabus. Depth is not required. Don't waste your time by going in depth of the concepts. That is really going to kill your valuable time in the preparation. But you have to cover all the corners. Suppose if you go for a speed control of a DC motor, there are many types of speed controls, right? So on all those things, you must have the basic knowledge. What is the name of it? How the speed control is done? But you need not to know about in-depth concepts of that speed control, right? So please keep this one in mind. That is, you have to cover the entire syllabus, not in depth required, right? The very first question is this question is from semiconductors, or I can say from electronics. Simple question. Even an intermediate student can answer this type of simple question. The first question is, the device which behaves neither as a good insulator nor a good conductor is known as. Yeah, very simple. It is semiconductor. Yes, we all know it is known as semiconductor. It's not a good conductor, not a good insulator, right? Semiconductor. Let's go to the next question. The next question is, identify the following chopper type. Identify the following chopper type in the figure below. In the figure below, he given one circuit. So he's saying that this is a chopper. What kind of chopper is this? He's asking. So there is a source, there is an inductance, there is a shunt switch, there is a diode, and there is a load. Now let's verify what kind of a chopper it is. Now when the switch is in open position, this inductor is charging like this. This inductor is having plus minus like that. Now what is the voltage across load? What is the voltage across load? Very simple. VL. So I'll write KVL minus S plus voltage across inductor. Voltage across inductor. So this load, I'll take just a minute. You will get confused. Voltage across inductor and voltage across load, I'll take in different way. So I'll take this one as V0, voltage across load. This is voltage across inductor. If I write KVL for this loop, now switch is in open position, please do understand. That is minus S plus VL plus V0 is equal to 0. So minus S. Now what is V0? V0 is equal to S minus VL. S minus VL. Now if you see, when the switch is in open position, yes, when the switch is in open position, yeah, so this output voltage V0 is equal to S minus VL. But if I close the switch, what happens? When the switch is in open position, this inductor is charging. Now this is going to exchange its terminals, that is going to reverse its terminals. Yes, that is going to reverse its terminals. Whenever current through inductor suddenly changes, see, I can say like V is equal to L di by dt, di by dt. Now see, I can say like when there is a sudden change of current through inductor, huge voltage will develop across that inductor. Now here, inductor reverses its polarities. Inductor current through inductor cannot change suddenly, but voltage across inductor will reverse its polarities. Now this voltage is getting added to this source voltage. If you observe, minus S, it is going to be minus VL. Then the total voltage is going to be, if you take minus common, S plus VL, voltage is getting added, voltage is increasing. Therefore this particular chopper behaves as a step up chopper. It is going to increase the voltage, right? Let's go to the next question. Which part of cable provides path for fault and leakage currents as the sheath is earthed at one end of the cable, one cable end? one cable end. Metallic sheath only, metallic sheath only. See, we know what is leakage current, that current which is flowing from cable to the ground. So for that one to happen, definitely there should be another metallic body. Which one is another metallic body in the cable, underground cable? Metallic sheath only, it is metallic sheath. See, these are the layers in the cable. See, this is a core or conductor, this is the core or conductor, this is the core or conductor. Above that we are going to put insulation. So this is insulation, this is insulation. After that we are going to put a bedding. After that, sheath, metallic sheath I am going to put. After that, metallic sheath we are going to put, metallic sheath. This is the metallic sheath. After that, I am going to put armoring for the purpose of protection. This is armoring. So these are, after that, in the last serving, right? In the last serving. So these are the layers of cable. These are the layers of cable. So this is core. This is core. So this is metallic sheath. Metallic sheath, I can say. Yes. Metallic sheath. So leakage current will flow from core to the ground. Metallic sheath is grounded to the ground through this metallic sheath. Through that metallic sheath. Answer is metallic sheath. Let's go to the next question now. If the diode clipping levels are set too low or the input waveform is too great, then the elimination of both the waveform peaks could end up with a dash shaped waveform. Now, see, I'm taking this sine wave. I'm taking this sine wave. Now, what that fellow says is, if the clipping is too low level, means if it is too low, this is not too low, this is not too low, that is too low, right? Now, all this got clipped. See, I'll mark the clipped part. I am going to mark the clipped part. So this part is getting clipped. This part is getting clipped. Then you are going to left with. Only this part. Only this part. I draw it here. This part. It is more or like it is looking like a square wave. The answer is square wave. Let's go to the next question. Which of the following conditions the number of poles and zeros of a transfer function source? All the root locus branches start at finite open loop poles and end at finite open loop zeros. See, we all know that number of branches of root locus is equal to number of poles or number of zeros, whichever is greater. And some branches of root locus will approach to infinity, or some branches of root locus will start from infinity. That is going to depend on the difference between the number of poles and number of zeros. But he is saying here that yes, he's saying that here that he want, see, he's saying that which of the following conditions of the number of poles and zeros for a transfer function source, all the root locus branches start at a finite open loop poles and end at finite open loop zeros. Come on here, very simple question, but that statement given by him is somewhat looking like clumsy, but very simply we can understand. That is, see, my system is having m poles and n zeros, n finite zeros, open loop poles and open loop zeros. Number of branches of root locus which are approaching to infinity is equal to m minus n. Now we all know that a root locus branch will start at a pole and ends at open loop 0. See, the note point here is root locus branches start at open loop poles, and ends at open loop zeros. Clear? Now, how many branches will be there? Suppose if poles are m branches will be there. All those branches must end at open loop zeros. If open loop zeros are not available, then that difference of branches will go to infinity. But he is asking all branches must end at zeros. There should be, the condition is m must be equal to n. The condition is number of poles is equal to number of zeros. Let's go to the next question. What should be the duty cycle of buck boost converter to have infinite voltage as output? V0 is equal to d by 1 minus d into Vs. If you want this part to be infinite, then d must be equal to 1. Then V naught is equal to 1 minus 1 minus 1, 1 by 1 minus 1 into Vs is equal to infinity. The duty cycle must be equal to 1. Let's go to the next question. Which of the following is an incorrect stage of nuclear power plant? Nuclear reactor. Yes, there will be nuclear reactor in the nuclear power plant. Heat exchanger will be there, alternator will be there, but this particular gearbox for changeable speed is not required in nuclear, I can say, power plant. So this is the incorrect one. See, our answer is this one. See, this is the answer. See, for nuclear power plant, all 1, 2, 4 are applicable. Third is not applicable. He asked which one is incorrect. So among these four, what is incorrect? Third one is incorrect. The third one is the answer. Let's go to the next question. Which rotational speed counting system consists of 7 gate rings, each marked with 0 to 9 digits on its rim, and all the rings together show the reading in kilowatt hour? This question is related to energy meter. See, number dial is required. Number dial is required. If you are done with your energy meter in your, I can say, academics, that is one of the simple theory question to ask. Okay, there is no much explanation in that. Let's go to the next question. Which force becomes noticeable when attempt is made to compress a solid? Repulsive forces. See, when you are attempting to compress a solid, definitely repulsive forces will produce. Yes, repulsive forces. Option 2 is correct. Let's go to the next question. Which of the following is incorrect for non-conventional type of generating station? Non-conventional. What is conventional? Conventional means, I can say, thermal. Thermal is conventional, where coal is used. That is conventional. Non-conventional means hydro, not hydro, sorry. I can say solar is non-conventional. I can say geothermal is non-conventional. I can say wind is non-conventional. So here the question is, which of the following is incorrect for non-conventional type of generating source? Produces low voltage. Yes, it produces low voltage, and that depends on I can say natural resources. Suppose if you go for wind power station, that wind speed may not be constant, therefore it produces low voltage. That is correct. Installation cost is less than running. Installation cost is less and running cost is more. No, absolutely wrong. Second statement is right, because for non-conventional there is no, I can say, running cost. Running cost is very, very, very less. Why? Because wind is the one which is running our, I can say, turbine. Right? Wind turbines are there, wind is running it. So wind will come from free of cost. Installation cost is more, running cost is low. Therefore, second is also wrong. Synchronous generators are used to produce power. This is wrong statement. That is our answer. He's asking which one is incorrect. Because synchronous generator is a constant speed generator, but non-conventional sources will not produce constant power. Why? Because those are going to depend on the nature. Suppose if you take a wind station, wind speed is not going to be constant always. It depends on several factors, atmospheric factors. Therefore, as the speed is not constant, we can't use synchronous generator. I have to use which generator? Induction generator. Now, directly supply to distribution system. Yeah, our answer is 3. Synchronous generator cannot be used in non-conventional way of energy generation. Right? Let's go to the next question. The Butterworth approximation is superior at and near at omega equal to 0, and near that Butterworth approximation is superior. Yes, at omega equal to 0. Right? Next question. All are theory questions only. There are 1 or 2 problems. Those problems are also very simple. Now here, look at this question. What is the full-scale deflection of an electrodynamic instrument if the actual load current is 0.5 amperes and the actual supply voltage is 120? So current is 0.5 and voltage is 120. So if you multiply this one, you are going to get to 60 watt. I have to put a full-scale deflection of 60 watts. Option is 3. Direct question. That is also Hall effect. The next question. The Hall effect cannot be applied in which of the following cases? He's saying cannot be applied. Yes. In the frequency measurement, we cannot apply Hall effect. It is not possible, right? That is also theory question. See, most of the questions are from application orientation if you observe. See, paper analysis is very important. You see, most of the questions are from application, synchronous generator, Hall effect, and that meter also, 60 watt, how we are going to, that meter can be used, right? Yeah. What type of step response is produced when poles are on the real and right side of the S plane? Yeah. He's saying that there is an S plane, this is sigma, this is j omega, and this particular one is S plane. Now there is a pole, and the real axis suppose say at -2, then transfer function of the system may be some k by s plus 2. Then what is its impulse response? Impulse response is inverse Laplace of a transfer function that is equal to k into e power minus plus 2t. Sorry, that is minus, yeah, this is minus ma. Yeah, I'll write here. This is minus. Why? Because this is a plus na. On the right side means it is plus. Right side plus. This is 0. This side numbers are negative, that side numbers are positive. So as it is plus 2, k by s minus 2, therefore k into e power minus 2t into u of t. Then you see at t tends to infinity, as t tends to infinity, that particular value impulse response is increasing. Read the options. Fixed amplitude oscillations. First of all, no oscillations. I got exponential power, right? Next, reach infinity with a damped oscillations. No oscillations at all. Reach to infinity without any oscillations. Yes, it is reaching to infinity. It is reaching to infinity without any oscillations exponentially. In fact, steady state value without any oscillations. No, it is not going to get any steady state value. Steady state output is infinite. It is infinite. Let's go to the next question. Which type of component increases when trivalent material is mixed with the pure semiconductor? Holes. Yes, holes are going to be increased. This is also one of the theory questions from semiconductor physics. Let's go to the next question. Yeah, this question we have to use our formula. What is the new reactance of a transmission line at the new base MVA rating of 111 kV if the 0.4 per unit reactance produces the same transmission line at a base of 75 MVA rating with a 10 kV? Very simple. See, he given old per unit value. What is the old per unit value? So I can say X old in per unit is equal to 0.4. Now how much is X in ohm? X in ohm is equal to 0.4 into V square base. What is the old base? What is the old base? 10 into 10 cube whole square by how much is S base? S base is 75 into 10 to the power of 6. You know the formula is X per unit, X in ohms is equal to X per unit into V square, V base whole square by S base, V base whole square by S base. Now I got this one in ohms. Now X per unit nu is equal to X in ohm into S base nu by V base nu whole square. Now if you come here, so X per unit nu is equal to how much is X in ohms? 0.4 into 10 into 10 cube whole square by 75 into 10 to the power of 6 into S base nu is 100 into 10 to the power of 6 by how much is the new voltage? New voltage base is 11 into 10 cube whole square. If you do, you are going to get the answer as 0.44, right? That was simple question it is. He given old per unit value on old base. I got ohmic value by multiplying its old base. What is the old base? 75 and 10. 75 and 10. After getting ohmic value, for any base, you are going to convert it to per unit by giving any base. So X ohms into S base by V base nu whole square. Let's go to the next question. The answer here is 0.44. Choice A suits very well. Right? Next question. Which modulation index condition is correct for maintaining the constant output voltage from the PWM pulse width modulation limiter? Modulation index greater than unity. This is also a directly theory question. Modulation index must be greater than unity. Then only that is possible. Let's go to the next question. Right? This is the following statement and give the correct answer according to the SCR gate triggering circuit. It provides accurate firing control over the required range. No, accurate is not possible. Second one, produces a gate signal of suitable magnitude and sufficiently short rise time. Yes, this is correct. Only statement 2 is correct. Only statement 2 is correct. Let's go to the next question. Which of the following is considered as the pressure coil of the electrodynamo type wattmeter? Always moving coil is taken in electrodynamometer wattmeter. Yes, moving coil is taken. Option 2. Let's go to the next question. Which of the following theorems is used to identify the resistance of the speakers that must be matched to the audio power amplifier to obtain the highest output? Highest output itself, it is saying that the maximum power transfer theorem. Answer is maximum power transfer theorem. Yeah, what if maximum power transfer theorem says the load impedance must be equal to source impedance if you want maximum power to be transferred to the load. But during maximum power condition to the load, the efficiency of the circuit is only 50%. 50% of the power is going to be wasted. Okay. Next question: which of the following characteristics is shown in the band elimination filter? Band elimination or band stop filter. Observe the characteristics. Now, this is not the band stop filter. See, initially gain is there. After that also gain is there. Somewhere in the middle gain is not there. It is stopping some band of frequencies to pass from input to output. I can say that that is band pass filter. This is low pass filter. This is a low pass filter. This is a high pass filter. This is a band pass filter. This is band reject filter or band stop filter or band elimination filter. That is choice for direct question. What is called as reference value that is expressed in power system network voltage, power and current and impedance rating? Yeah, base value is taken as reference. That is damn easy question. See, what is a per unit value? Absolute value by base value, absolute quantity by base quantity, and per unit quantity is not going to have any units, right? Not unit value, not per unit value. He's asking what is called the reference value. Reference is always base quantity, right? Yeah. Let's go to the next question. What type of energy conversion happens in hydroelectric power station? Potential energy will be converted to, I can say, like electrical energy, right? Potential energy is converted of water, is converted for the production of electricity. That is very simple thing, right? Yeah. Next question. What is the base kV on LT side, low tension side of transformer? If 400 kV base kV on HT side of the transformer, or voltage rating in LT side and HT side is 1000 and 5000. See, rating of the transformer is 1000, 5000. See, this is primary side, this is secondary side. On LT side, suppose if he is taking 400 as the base, then HT side how much he has to take? So the relationship is V2 base by V1 base must be equal to K, where K is the transformation ratio. What is transformation ratio? V2 by V1 or N2 by N1. I do not have N2 by N1, therefore I can take V2 by V1. What is V2? 5000 by 1000, it is equal to 5. That implies V2 base is equal to 5 into V1 base. So V2 base is equal to 5 into V1 base is how much? V1 base is 400 kV. How much that is? 400 kV. Therefore it is 2000 kV is the base. 2000 kV. So he's asking for LV side or HV side. Just check it. He given which side he given. So he's asking V2 base or V1 base. What is the base kV on LT side of the transformer? Okay, he's asking LT side. He is asking for V1 base. Therefore, he given this one as V2 base. Sorry, I have to correct it. I'm going to correct it. Just observe. I'm correcting it. So yeah, come on here. He given. Here I have to correct. Here I have to correct. He given V1 base. He's asking for V2 base. Right? Now, observe here. So, yeah. Yeah. Here, V2 base he given. How much is V2 base he given? Yeah. V2 base he given as 400. He given V2 base as 400. V1 base he is asking and K equal to 5. So, V1 base is equal to V2 base by K. Yes. V1 base, let me select. V1 base is equal to V2 base by K, that is equal to 400 by 5, that is equal to 80 kV. The option is 3. Option is 3. But all it lies in the understanding of the question. Let's go to the next question. Which of the following flip-flop inverts the output corresponding to every leading edge of the clock signal when the input signal is high? Inverting. See, SR flip-flop, D flip-flop are not going to invert. Flip-flop, see, every positive edge means it is flip-flop only, but not latch. So SR will not do, flip-flop will not do, D will not do. D is a data flip-flop, okay? Just it is going to transfer from input to output, that's all, from one side to another side with respect to the passage of the clock, right? So T flip-flop will do that. T flip-flop will do that, okay? Let's go to the next question. Which of the following combination circuits is used to perform the addition of 2 bits? 2 bits addition is half adder, 3 bits addition is full adder, right? So it is half adder. Let's go to the next question. Which type of circuit is made by parallel resonance? Which type of circuit is made by parallel resonance AC circuits? I can say during parallel resonance, I can say impedance is very high. During parallel resonance, impedance is very high. In fact, I can say input impedance is infinite. Input impedance is infinite. Why? Because see, I'm taking only LC. I'm taking only LC, not RLC. Yeah, I'm taking LC. Observe. Suppose you are connecting a current source here. You are connecting a current source here. This is J2. See, parallel resonance means XL must be equal to XC. Magnitude XL must be equal to XC, either parallel resonance or series resonance. Then how much this should be? This is minus J2. Then what is the impedance seen from here? Zin. How much is Zin? Zin is equal to J2 into minus J2 by J2 minus J2, that is equal to infinity. This particular circuit is not taking this particular current source. It is rejecting it. Therefore, it is a rejector circuit. It's a rejector circuit. In fact, I should not give current source here. Current in open. See, current never exists in open circuit. I should not give current source here, right? So fine. Instead of current source, I'll take it as voltage source. Instead of current source, I'll take it as voltage source. Then how much is the current that is flowing? How much is the current that is flowing? 0. The current that is flowing is equal to 0, because these two behaves as an open circuit. These two combination behaves as an open circuit. In open circuit, current is 0, right? Let's go to the next question. Yeah, why is Ampere's law not applied to finite conductors? He's saying that for finite conductors, why Ampere's circuit law is not applied. The magnetic field in a conductor is in uniform condition. No, the magnetic field in a finite conductor is not in uniform condition. Yes, that is the reason why we won't apply Ampere circuit law. Let's go to the next question. See, mostly are statements and applications. Statements and applications. This is one of the easiest question, but there should be some question framing. It looks like the question framing is not completely correct. What is that? According to the above circuit, what is the value of voltage across capacitor after shifting the switch from position 1 to 2? When the switch is in position 1, this capacitor fully charges to a voltage of E. Now, when you are shifting that switch from 1 to 2, now the voltage across capacitor is E at that instant. Suppose at t is equal to 0, if switch is moved from 1 to 2, then voltage across capacitor at capacitor at t is equal to 0 is E. But as there is no source, the voltage across capacitor keep on decreasing with respect to time. As there is no voltage source, the voltage across capacitor keep on decreasing with respect to time. That expression for voltage across capacitor is, I can give you like this. That is Vc is equal to E into e power minus t by Rc. E into e power minus t by Rc, right? But that option is not there. See, this is not correct. E power plus st given, minus 1 by Rc is not correct. 0 is not correct. The answer is E, option A. Let's go to the next question. Which of the following is the correct statement for parallel resonance circuit? For a parallel resonance circuit, the circuit impedance becomes purely inductive. No, this is absolutely wrong. The value of resonance impedance will be very high. Yes, previously itself we saw the impedance is infinite if you are taking only L and C. The ratio of L to C is very small. No, the circuit current is very high. No, wrong. Current is very less in parallel resonance. Let's go to the next question. Which of the category is considered cycloconverters? Cycloconverters are what? AC to AC only. Frequency changes are cycloconverters. AC to DC are rectifiers, phase control rectifiers. DC to AC is inverter. DC to DC is a chopper, right? And AC to AC is cycloconverters. The purpose is to change the frequency. Option 2. Let's go to the next question. In which of the following instrument there are No errors due to stray magnetic field. Say magnetic field is not going to give any error in electrostatic meter. Yes, the answer is electrostatic meter. It is unaffected by stray magnetic field, right? Next question. Yeah. What is the voltage across 20 ohms in the above circuit? So he's asking the voltage here. Very simple. I apply KCL. So V, see, V minus 50 by 15. This is the current. This current is plus V by 20 plus V minus 100 by 30 is equal to 0. 30 is equal to 0. So V into 1 by 15 plus 1 by 20 plus 1 by 30 is equal to 50 by 15 plus 100 by 30. 100 by 30. I'll simplify it. Observe all of you. So I can take this one as, I'll multiply, I'll write this one as 2 by 30. I'll write this one as 2 by 30 plus 1 by 20 plus 1 by 30 is equal to, this can be written as 100 by, this can be written as 100 by 30 plus 100 by 30. This total will be 2 into 100 by 30 into 2. That's all. Now simplify this, you are going to get the V. Simplify that. This is the reference taken. This is 0 volts. You're going to get that V. That V by resistance will be the current. Or just he's asking about V only, na? Yeah, he's asking about V. Simplify this one. Simplify this one. You get that voltage V. You get that voltage V. Simplification, I'm leaving it to you, right? Let's go to the next question. Identify above clipping circuit shown in the figure. Identify the above clipping circuit shown in figure. Positive diode clipping circuits, negative diode clipping circuit, clipping of both half cycles. Yeah, it will do the clipping of both half cycles. Why? Because for positive half cycle, this particular diode will conduct, this particular diode will conduct, right? Yes or not? For negative half cycle means if this is minus, this is plus, this particular diode will conduct. Therefore, it is going to do both the half cycle clippings. It is going to do both half cycle clippings. Let's go to the next question. Which of the following spin arrangements shows paramagnetic material? Option 2. See, this way, in zigzag way, it is arranged. This magnetic force lines or magnetic dipoles, I can say, yes, paramagnetic material. Let's go to the next question. What is the minimum current required for full-scale deflection of electrodynamic instrument? It is 100 milliamperes. 100 milliamperes. All are theory and memory-based questions or application questions only, right? Next question. Which type of test is not performed by DC series motor? See, DC series motor should not run on no load. We know that. What test is run on no load? Swinburne's test is going to be conducted on no load. Therefore, this should not be conducted on DC series motor. Why? Because DC series motor should not run on no load, right? Let's go to the next question. Yeah, comment your answer. If you know the answers, please comment. If you know the answers, please comment, right? Yeah. Which of the following statements is incorrect for induction motor? It is a self-starting motor. Yes, it is a self-starting motor. Three-phase induction motor is a self-starting motor. This is correct statement. No extra supply is required for DC excitation. Yes, as itself, it is a singly excited machine. DC, see, induction motor is a singly excited machine. Therefore, no separate excitation not required. But if you go for a synchronous motor, it requires separate DC excitation. Now, last third one, you see, it is operated in all power factor. No, it always operates at lagging power factor. This is wrong. This statement is wrong. Okay, it is simple in construction and less costly. This is also correct. My answer is third answer. Why? Because he's asking which one is incorrect. Which one is incorrect? Let's go to the next option. Which of the following rules is found in the last step of root locus? You know, remember, angle of departure and angle of arrival are the last steps of root locus. Angle of departure and angle of arrival. Angle of departure and angle of arrival. You know, we have some rules for sketching root locus. In that, the last step is angle of departure and angle of arrival. Next question. What type of analysis is now used for change from one steady state to another at a particular time? Yeah, sudden change means will give transient analysis, will give transient state analysis, right? See, what type of analysis is now used for change from one steady state to another at a particular time? It is transient analysis only, right? Next question. What is the gain margin in dB of the system if the gain is 1 by 15.7? See, the very simple question it is, gain margin is equal to reciprocal of gain. reciprocal of gain. So 1 by 15.7, this is equal to 15.7. Now gain margin in dB is equal to 20 log of 15.7, but approximately I'll take it as 20 log of 15. I'm leaving that 0.7. Now 20 log 15 can be written as 20 log of 5 plus 20 log of 3. See, you have to remember 20 log 2, 20 log 3, and 20 log 5. Those three, if you are able to remember anything, you can find. 20 log 5 is, I can say, 20 log 3 is, this is 15. 20 log 5 is 15 plus 20 log 3 is 9.5. So approximately it is, how much it is? 24.5. 24.5. See the answer which is very near to that. See 23.9. So all these answers are approximate. That's why, see, none of the option is near to 24. This is far away, this is far away, this is far away. For our option is 23.9. So 20 log 2 is 6 dB. 20 log 3 is 9.5 dB. 20 log 5 is 15 dB. So you have to remember these values. You have to remember these values. Fine. Yeah. Let's go to the next question now. Which type of the system is not included in electromechanical conversion? Electromechanical conversion, electrical system, yes, it is there. Magnetic coupling system, yes, it is there. Mechanical system, it is there. Thermocoupling, yeah, thermocoupling is nowhere related with the electromechanical energy conversion, right? Next question. This question is very simple. Yeah, this is from control system, that is from block diagrams. Yes. Now this is the output. This is plus. This is also plus. This is how much this is. Suppose if x is coming, this is xg3. If this y is coming, or no, that is also x. That is also x. Why? Because if this is x, this is also x. This is also x. How much this is? Plus x into g4 by g2. Now that y is equal to xg3 plus x into g4 by g2. That implies y by x is equal to g3 plus g4 by g2. G3 plus G4 by G2. Choice 3 is the answer. Choice 3 is the answer. Let's go to the next question. Let's go to the next question. Which type of circuit is very similar to that of combinational circuits along with the feedback? See, what is the difference between combinational circuit and feedback? But he's asking which of the sequential circuit is same as that of or similar to that of combinational, means the one which is not clock. Which one is not going to work with respect to clock? Asynchronous. Yes, asynchronous sequential circuit. Yes, asynchronous sequential circuit. Next question. Which circuit switches the operation of the inverter between the battery and the charging modes according to the main availability in PWM inverter? Changeover circuit. Yes, this is also direct question. Changeover circuit is going to useful in that particular process, right? Next question. What is the time constant of RC circuit where R is equal to 20 ohms and C is equal to 400 microfarad? See, tau of an RC circuit is equal to R equivalent to C equivalent. It may be series RC or parallel RC or any combination of R and C. The time constant formula is R equivalent into C equivalent. What is the value of RE given? 20 ohms into 400 microfarad. How much it is? 8,000 into 10 to the power of minus 6. So 8 into 10 to the power of minus 3. 8 into 10 to the power of minus 3. Simply it is 8 milliseconds. The option is 2. Option is 2. Choice 2 is the answer. Let's go to the next question. A very small air gap in the induction motor cannot cause, he's asking, cannot cause noise, pulsation losses, a magnetic pull, an increase in the overload capacity. See, the air gap cannot give increasing the overload capacity, right? Option is 4. Let's go to the next question. Which is the correct stability condition for the following characteristic equation? So he's asking about the stability. Stability of a given characteristic equation is found by using RH criteria. Apply RH criteria. This is S cube, this is S square, this is S power 1, this is S power 0. How to fill? This is 1. Yeah, this coefficient. After this, leave this. Then after that, 6. After that, 0. 1, 6, 0. After that, yeah, 5, 30, this is 0. Now, if you calculate it, this is going to be 0, this is going to be 0, this is going to be 0. See, the last row is nothing but last element. Always do remember one thing, last row is nothing but last element. You have to calculate the last row. Last row of any RH tabulation is the last element of the given characteristic equation. If you observe, one complete odd power row became 0. Therefore, two symmetric roots are there with respect to origin. And then are there any sign changes? Are there any sign changes? This is plus, this is plus, this is plus. Now what is the auxiliary equation? Whenever a complete odd row is becoming 0, its above row is taken as a auxiliary equation row. What is that? Is 5s square plus 3. Now derivative of auxiliary equation coefficients are filled in that row 10 and 0. So this is 10, this is 0, this is also plus. No sign change in the first column of row array, and there is a one complete odd power row became 0. Which row? SS power 1 row became 0. Therefore, how many roots are symmetric with respect to origin? Two roots are symmetric with respect to origin. This is the combination, and remaining one root will be in the left half of the plane. If you see that the poles combination or poles location in this plane, we can easily say that the given system is marginally stable. Option 1 is the answer. Let's go to the next question. What is done when a 2 by 2 element matrix under change matrix change the diagonal elements and changes the sign of the remaining elements? See, there is a 2 by 2 matrix A, B, C, D. What we do, if I want to find the inverse of it, any matrix inverse is what? Any matrix inverse is what? Adjoint A by delta A, adjoint A by delta A. What is saying? He is changing these and he is changing the sign of these. Yeah, he's saying what is done when a 2 by 2 matrix change the diagonal elements, exchange. This is exchange diagonal elements and change the sign of the remaining elements. Diagonal elements are exchanged, and I'm not dividing with this I can say like 1 by AD minus BC. I'm not doing it, right? Delta I'm not doing it. Then this is simply, this is the inverse of ABCD. This is inverse of ABCD, that is equal to det of AD. That means what? AD minus BC. Now this is nothing but what? Adjoint A. This is what? Det of a matrix A. I'm taking this matrix as A. This matrix as det of A. So this process is nothing but finding adjoint of matrix, adjoint of the matrix, right? Let's go to the next question. Which type of filter is used to transmit every type of signal? All pass filter, all frequency signals. The filter which allows all frequency signals from input to output is called as all pass filter or all pass system. Option is 2. Option is 2. Let's go to the next question. Which of the following methods is used to inject and or absorb the reactive power in the transmission line? Yeah, tap changing transformer will not, induction voltage regulator will not, shunt reactor. Yes, what is asking? Which of the following methods is used to inject or absorb reactive power in the transmission line? See, transmission line will see, it is going to absorb reactive power. It is going to absorb reactive power. Either option 4 or option 1, both are correct, man. Not only synchronous phase modifier. Synchronous phase modifier is a synchronous motor, underexcited. See, I can say it may be underexcited or overexcited depending on the requirement. And a shunt reactors also. Shunt reactor will absorb reactive power. When the condition is over voltage condition, current effect is there, then we are going to use shunt reactor. So it is going to absorb reactive power. It is going to absorb reactive power, option 1 and 4. But that fellow given as a synchronous phase modifiers only. We don't know what is the reason why he given phase option 1 as the answer. Option 1 and 4 both are suitable. Why? Because he's asking which of the following methods is used to inject or absorb reactive power in the transmission line. So synchronous phase modifier means either overexcited synchronous motor or underexcited synchronous motor means okay, fine. Now it is correct. Only option A. Only option A. He's asking which can both absorb and supply. It is going to only absorb. It is only absorb. Yes, he is right. This can absorbs or supplies. This can do both the duties. Therefore, option 1 only correct. Option 1 only correct, not 4. So 4 can, see, tap changing transformer will absorb reactive power as it is a transformer, right? Induction voltage regulators absorb reactive power, but shunt reactive power absorb reactive power. But phase synchronous phase modifiers will both absorb as well as supply. Let's go to the next question. How many poles are in the left half of this plane if two sign changes in the first elements of any row in route array? Number of RHP is equal to number of sign changes in the first column of route array. In the first column of route array, How many are there? How many are there? Yes, 2. Let's go to the next question. Which of the following properties is correct for an electrostatic instrument? Uniform scale? No. Use very large magnitude for deflection? No. Low cost? No. Design for large voltage? Yes. Electrostatic instruments are designed for dealing with large voltages. That is very much true for electrostatic instruments. Next question. Which of the following speed controlling methods of DC motor is work as a Ward-Leonard method? Armature voltage control. This is direct question. Direct question. No more explanation required there. Right? Next question. Let's go to the next question. Which of the following factors is higher in the squirrel cage induction motor than the slip ring induction motor? You know, squirrel cage induction motor is more efficient and more robust. The answer is efficiency. Answer is efficiency. Let's go to the next question. Which of the following is incorrect for the per unit impedance? Per unit impedance is equal to what? Absolute value by base value. Absolute value by base value. What is option A? Actual impedance by base impedance. This statement is correct, but he's asking about incorrect. Therefore, this is not the answer. This is not the answer. Statement is correct, but that is not the answer. Second one, actual impedance into base voltage by base volt times. So the second formula is actual impedance in ohms into S base by S base in MVA by voltage base square in kV. This is also correct. Second is also correct. It means statement is correct, but this is not our answer. This is not our answer. Third one, base megavolt amperes by square of actual impedance multiplication is missing here. This is wrong. This statement is wrong. This is our answer. Last one, base kilovolt amperes into actual impedance by square of the this is correct. This is correct. Statement is correct, but answer is wrong. So our answer is option 3. Our answer is option 3, right? Let's go to the next question. Which among the following materials has the highest thermal conductivity? Aluminium. We all know that. That is also direct question theory question. Aluminium. Next question. Which of the following methods of voltage control in a power system is incorrect? Read it. Excitation control of generating station, we can do that, but that is practically not preferred. So excitation control at the generating station is not preferred for the control of transmission or distribution voltage levels. That is not done, but that is also one of the possible method. Induction regulator, yes, we can do. Shunt capacitor, we can do. Series resistor, no, we are not going to take up this one because it causes unnecessary power loss. Suppose if you want to reduce the voltage, we never go for a series resistor because there is huge power loss, right? Let's go to the next question. Let's go to the next question. What is the input RMS voltage of a full wave rectifier if the output DC voltage is 9? What is VRMS? VRMS is equal to VRMS of a full wave rectifier. Full wave rectifier. See, this is your full wave rectifier output. Full wave rectifier output is Vm by root 2. Vm by root 2, right? So VRMS, how much he given? So sorry, he asking about DC, not that relationship is correct. That relationship is correct. Let it be. Then VRMS is equal to Vm by root 2. VDC means V average is equal to 2 Vm by pi. 2 Vm by pi for full wave rectifier. So 2 into Vm is what? So Vm is what? Root 2 times of VRMS. Root 2 times of VRMS by pi is equal to 9. This is what he given. So he's asking input RMS value. Therefore, VRMS is equal to 9 into pi by 2 root 2. If you solve this, nearly 10 volts you get. Nearly 10 volts you get. Yes, the choice is 1. The choice is 1. Let's go to the next question. Which of the following energy source systems produce power in megawatt capacity compared to other? Solar, nuclear, tidal, biomass. We all know that nuclear can provide more and more energy. That is the advantage of nuclear. That is the advantage of nuclear, right? So these are the first, I can say, 60 questions of previous SJVNL electrical paper. Next 60 questions also we are going to take up soon. See, again, I'm going to give some suggestions to you when you are going to prepare for this SVJN. You have to cover lots of syllabus, all the corners of the syllabus without leaving anything. If you take exams like GATE, in GATE examination, there are some important areas. Suppose if you take power system, fault analysis, stability analysis, these are the important areas, right? And load flow studies, these are the important areas. The unimportant areas are generating stations and all. But for this kind of examinations, generating stations are very important. There are 2 to 3 questions in this paper from generating stations. We are going to solve in the next section of solving this paper. We are done with the 60 questions of the paper, 60 very good questions of the paper. Remaining 60 questions we are going to take up in the next session of our live. Soon we'll inform you when it will be, right? Join your hands with YourPedia. YourPedia started its module for mentoring to the students. We are unique. We have a unique way of giving, I can say, like training for these kind of examinations to the students. So join your hands with YourPedia. All the best, man. Thank you.